Today, we're at NASA Johnson Space Center here in Houston.
Why? To learn about the International Space Station, or the ISS, and the people who make it work. The ISS is a huge laboratory being built in orbit. Scientists on the ground will send their research to the station to be performed by astronauts from all around the world.
There are 16 countries participating in the largest and most expensive laboratory ever built in space. By working together rather than competing, top scientists from around the world can collaborate and share information.
Using the United States Space Shuttle and various rockets from other countries, it will take more than 100 space flights to assemble the 100-plus components of the ISS.
The ISS will be about the size of a football field. It will weigh approximately 1 million pounds, or over 100 adult elephants, approximately total the volume of a 747 jumbo jet, and generate enough power to light up more than 40 average homes. And if you'd like to study the effects of gravity, you'd want to go into an anti-gravity room. But since there's no such thing on Earth, we have the ISS.
On board the ISS, a microgravity environment is created. This is where the effects of gravity are reduced compared to those experienced here on Earth. You see, the ISS is in a continuous state of free fall around the Earth, causing the astronauts and objects inside to appear to float and be weightless. You can experience free fall when you jump off a diving board. You are practically weightless until you hit the water.
But how does the space station stay in orbit if it's falling towards the Earth?
Here's an analogy. 300 years ago, a great scientist by the name of Sir Isaac Newton imagined an experiment in his head. He pictured a cannon on top of a very tall mountain. When he fired the cannonball would soon fall to Earth. But if he used a cannon with more power, the cannonball would go halfway around the Earth before it landed. And if he used a super-duper cannon, the cannonball would go so fast that it would fall at the same rate that the Earth's surface is curving away beneath it. This super-fast cannonball would never hit the Earth. It would be in orbit. And if you were sitting on the cannonball, you would feel weightless. NASA uses rockets instead of a cannon, and the ISS instead of a cannonball.
By understanding the effects of gravity, we can learn why things behave the way they do.
Take the human body, for instance. How does a microgravity environment affect the residents of the ISS? One of our guests will fill us in.
The ISS will also give students like you first-hand experience with the space program. Get this, from your own classroom, you can talk via amateur radio to the astronauts on board the ISS.
Or learn about Earth from the unique perspective of space with EarthCam, which stands for Earth Knowledge Acquired by Middle School Students. The EarthCam has already flown on 5 shuttle missions involving students nationally and internationally. Visit the EarthCam website to learn more.
And don't forget, later in the show you'll be constructing your own model of the ISS. But before we do that, let's learn about some of the parts that make up the space station.